So let's start with something we know, v4 addresses. v4 addresses are 32 bits long, and if you say what's 2 to the 32nd, you can actually see what that number is. It's a large number, but it's not huge. If you look at an IPv4 address, they tend to be in what we call a dotted decimal format, 4 8-bit octets separated from each following one by a dot. If you got leading zeros, you can drop those. So there are some examples down at the bottom of what v4 addresses look like. You're used to them. v6 addresses are a little bit different. They're longer. They're 128 bits instead of 32 bits, which means you have this 2 to the 128th gigantically huge number. And those are normally represented in a colon-separated format. So you might have 8 sets of 4 hex digits, and the chunks, instead of being separated with dots, they're separated with colons now. And if you got leading zeros within the chunk, you can omit those. And there's a really cool feature whereby if you have a run of zeros, you can actually replace that run with colon, colon. You can only do that once, because otherwise it wouldn't be able to figure out where the zeros go, but you can do it once. So you can see some examples down there on the bottom of IPv6 addresses and what they look like. Now we could do a quick quiz and basically look to see how these different addresses appear. How about that first one? Does it look okay? Valid or invalid? Looks all right to me. How about the next one? Valid or invalid? Still looking okay, I think. How about C and D? Dead beef? Dead beef okay? That's actually a legitimate hex value, believe it or not. We can kind of keep going down the line looking at those. I'll tell you that there are a couple that should make you nervous. If you look at like number 4, or I should say F rather, if you look at it, it's got 2 double colons in there. And that's going to be a problem. How are you going to know where to put in the zeros to fill things out? You don't know what the apportionment should be, right? How about that colon, colon at the bottom? That's actually a valid one too, believe it or not. So if you go ahead and want to go to the cheat sheet the way I always did when I was doing homework in school, you can actually see what the problems were. So we had the double colons. You went ahead and had 9 chunks instead of 8 if you were able to go ahead and count from sitting in the back or whatever. You had one that had a G, and of course G is not a valid hexadecimal digit. But the rest of them were all valid. Let's talk about prefixes a little. Again, this is something we all are familiar with, or at least many of us may be. And in the old days, we used to have /8, /16, /24s. And you could go ahead and figure out how many of those you could potentially have. And you could also figure out how many of addresses would be in each of those size blocks. The problem is some were too big and some were too small. So then we went ahead and got CIDR, or classless interdomain routing, and we had the ability to have much more granularity, much more flexibility. You could have anything from, let's say, a 27 all the way up to, say, like a /12 or /13, whatever it might be that you needed. And of course, a lot of times v4 subnets are 24s. Well, v6 uses prefixes too. It's just they tend to be a bit bigger. So you might have a /32 or a /48 or a 56 or a 64. And when you go ahead and are given that prefix, you can think of it as getting a series of /64 subnets. So if you got that /48, we already talked about that being like 65,000 subnets. If you got a smaller allocation, just a 56, you'd still get 256 of these big subnets that you could use. Each of those subnets is going to have that huge number of addresses you see at the bottom, more than you will ever need. When you go ahead and are getting space, there's actually some pretty well-defined rules in terms of what you're going to go ahead and get. Large sites, most sites will get a /48. Smaller sites, the ones that only need a couple of subnets over a 5-year period, are going to get a /56. If you only need one subnet, then you're going to go ahead and just get a /64. But the reality is many ISPs are just going to always give you a 48. A host just gets a /128, a single address. And the other rule I'll tell you just generally is that all subnets at most sites are going to be /64s. You can try and be clever, you can try and be cool, you can try and do something else, but you're just going to hurt yourself. Make your subnets /64s. One of the things that sometimes baffles folks about v6 is the fact that there are different types of IPv6 addresses, and people get really hung up on this. So I felt I had to go ahead and include a slide about this, but let me give you a couple simple rules. Just like in v4, there are global unicast addresses. Those are the ones you will normally care about. There are also things like link local addresses that you're going to see from time to time, and you've still got things like a loopback address. Folks who are familiar with like 127.0.0.1, that's the equivalent for v6. But the reality is, most of that stuff you don't need to worry about. If you want to understand how they fit in, I've got a slide. You can look at the slide. You can see how it all fits together. But remember, the global unicast IPv6 addresses are the ones you're generally going to care about. You'll also hear people referring to things like Anycast when we talk about v6. And Anycast is sort of an interesting thing. It uses the concept of announcing the same address space from multiple locations. And then the routers, through their own magic, go ahead and have the ability to go ahead and route you to the closest of those. The nice thing about that is, let's say one of those nodes goes down. The routers automatically take you to the correct alternative place. So if you hear people talking about Anycast, just think a prefix advertised multiple places at the same time. When you start looking at v6 systems and actually see what's there, don't be shocked when you see multiple addresses. Remember, we talked long ago about what the original plan was. Oh, if you're multi-homed, you'll have multiple addresses. Well, even if you're not multi-homed, you're going to go ahead and have multiple addresses, but that's not a big deal. Don't let it shake you up. Here's an example of what a system might look like on Linux that goes ahead and is running v6. So it has that bolded thing there. It goes ahead and shows you a 2001 address. That's a global unicast address. That's the one you care about. It also shows you a link local address, an FE80. The reason you want to know that both are there is, in some cases, you may only see an FE80 address. That does not mean you are connected to anything yet. That does not mean you can send v6 traffic to the internet. So you're looking for something that's like 2000, 2001 when you're connecting. Remember, we talked also about link local addresses. Well, there's that 127.0.0.1 down on the bottom, the v4 version, and there's ::1/128, the v6 version. People sometimes wonder, well, how do addresses get on interfaces? And in the IPv4 world, you know how that happens. For end users, it usually happens via DHCP. They're given a subnet mask, router addresses, domain name servers, all this good stuff. That all comes usually to an end user via DHCP. Servers sometimes also get addressed via DHCP. They may have a special configuration that only they get handed, but the reality is many times v4 servers may be manually configured or configured with something like Puppet if you have a lot of them. But the reality is that static addressing is still used for v4 servers. In the v6 world, things are a little bit different. There's something called SLAAC, or stateless auto-configuration. And what it goes ahead and does is it runs on a router instead of on a DHCP server, and it goes ahead and hands addresses to your customers if you're an ISP. It's going to go ahead and basically be stateless. There's no state that gets created when it goes ahead and runs. So it's a little different than DHCP. DHCP maintains a record, essentially, of who gets what. So, given SLAAC doesn't keep track of that, how does it do it? How does it know it's not going to give you an address that's going to conflict that it's already given to somebody else? Well, the kind of cool thing it does is it builds your IPv6 address from the address of your hardware Ethernet card. That hardware Ethernet card has a unique address. There should never be a duplicate MAC address on a hardware Ethernet card. And what they do is they go ahead and use that hardware Ethernet address, which is 48 bits long, and they kind of like rip it apart and stuff stuff in the middle to go ahead and create a 64-bit identifier. Remember I told you subnets are always going to be 64 bits long? Part of the reason why is the addresses that you're going to go ahead and be building from this thing, the EUI64 addresses, they're also going to be 64 bits long. The front half of that 128-bit address, it's going to come from the network and will basically be unaffected by this. Now, in the event there are geeky folks in the audience, I know you're out there, you're among friends, but nonetheless, the point is that if you are a geek, you may go ahead and say, well, boy, this is not so hot. If my address comes from my hardware Ethernet address, they're going to be able to track me. They're going to know every time I connect via v6 who I am, because my MAC address is never going to change. And that's true. The good news is that you have an alternative address format that's also available to you, these things called IPv6 privacy addresses. And what they essentially do is assign a random value to you for that lower 64 bits. And those addresses may also change over time. So if you're worried you're being tracked, go ahead and hit it again, and essentially it'll give you a new random address. And this is usually the point where folks jump up and say, well, that's a nice thing, but it's not what I really want either. The problem is if you assign random people random addresses, how do I know who I'm dealing with if I run into abuse? If there's a botted machine on v6 with a privacy address, how do I map that to a user? And the reality is unless you do some additional monitoring, that's going to be really hard. So one thing you should know about is something called NDPmon, and it basically is sort of like ARPWatch for v6. And if you're going to be having users with these privacy format addresses, it's really going to be to your advantage to consider running NDPmon. It may also be possible for you to go ahead and map IPv6 addresses to users at the time they connect. So you might be doing something like network access control. And if you're doing that for v4, you may want to plan to do that for v6 too. Users can enable or deselect privacy addressing. Windows, it's enabled by default. Thank you, Microsoft. From an abuse point of view, it makes it a lot harder to track those sorts of botted machines. On the Macs, the opposite is true. They're disabled by default, but people can go ahead and enable them. Linux is like the Macs. Again, you can go ahead and enable or disable them. So what you really want to go ahead and do is understand that if it is indeed a life or death thing for you to have privacy, these things are still not perfect. Remember, we talked about how people can still go ahead and track you. So if you're some sort of political dissident and you're worried that the regime is going to track you, do not rely on just this for your privacy. Here's examples of how you can disable privacy addressing for XP, Windows 2003, Vista, and 2008. Stole this slide from the DREN folks. They're doing a great job. They're the exception to the rule about federal networks not being v6 enabled. DREN's doing a great job. There is a stateful alternative to SLAAC, and that's DHCP v6. And essentially, it's like DHCP for v4, except it doesn't have universal support. So if you're on an Apple, as I am, unfortunately, you're not going to have native support for DHCP v6. You can go ahead and build a third-party application for DHCP v6, but it's a product that is actually coming out of Poland. And because the guy is working on his PhD, all that they're doing right now is sort of doing critical bug fixes, and development is otherwise kind of stalled. So, this is not ideal for a production product. You really don't want people having to download code from Poland just to be able to get an address on your network. Okay, we talked a little bit about getting your DNS servers to go ahead and be v6 aware, the fact that they need to know about things like quad A records, and that their access can be v4, can be v6, doesn't really have to be v6 right now. Recent versions of bind, thumbs up, you're going to be in good shape. One thing we didn't talk about previously is the fact that your offsite secondaries should also be v6 aware. So if you've actually got servers, secondary servers that are offsite, make sure you also visit with them. They may go ahead and be running some version of some ancient DNS software that may not be v6 aware. And if that's the case, they'll need to upgrade. I went ahead and showed you an example of going ahead and resolving a host when we first got started. We looked at UCLA at that point, but the point is you can go ahead and look at things using tools you're already familiar with, like dig. If you're using dig for v4, you can look at an A record and see what's there. In the v6 world, you're going to go ahead and still use dig. You'll just ask for a quad A record instead. Inverse address records are also going to be available to you. So for example, in the v4 world, you might use dig-x to go ahead and see what numeric IP resolves to. In the v6 world, you're going to use dig-x as well. you're just going to go ahead and be providing that colon separated value instead of the dotted quad. Sometimes folks say, well, I'd like to do this stuff, but I don't have a Unix host, and I still want to go ahead and find this stuff out. Where can I do it? Well, there are some web-based dig interfaces you can use too. One problem you'll run into is a lot of IPv6 addresses aren't going to even go ahead and have inverse address records. And that's because think of how many addresses you'd have to create if you were doing this. It's the sort of thing where you're going to go ahead and basically have a semi-impossible task for you to try and pre-populate millions of these. So there are a variety of different approaches that folks have tried. Some people suggest dynamic DNS, not real wild about that. But there's a unique approach that Ron Beresma of DREN suggested, where basically they sort of build them on the fly based on what's seen in the network. So this is a case where if you have the ability to kind of dig into what's on the network and take a look at what sort of state exists there, you can go ahead and map the v6 to the v4 in a kind of interesting way, but see Ron's slides for details. One of the other things we should go ahead and discuss is, let's say I do have v6 and v4. Which one should I use? Now, if you're kind of a tech enthusiast, you just automatically might assume, well, God, if I got both, I'm going to use v6 because v6 is cool and I want to be progressive and so forth. But think about that a little bit. If I'm just interested in moving bits and I got my choice of both, one's proven, one's stable, one's been there forever, you know, maybe I'd do v4 instead. So the point is that you need to be thinking about what the precedence should look like. Sometimes folks will go ahead and do something like actually have two different host names, one that's v4 and v6 and one that's v6 only. That way allowing folks to go ahead and sort of explicitly choose which they prefer if they want to force it. Other times you may just wonder, well, gosh, which one is my system going to, or what IP address do I have? There's a thing called whatismyv6.com that will actually tell you what address you currently are using. There's also add-ons you can go ahead and stick into things like Firefox that will show you the IP addresses that you're going to. And it will go ahead and give you a green address for a v6 address and a red address for v4 addresses. It seems a little harsh to make them red, but whatever. But the point is if you got v4, v6, you really need to think about how you want your traffic to go ahead and go and what the right precedence would be. Sometimes you're going to have connectivity that's going to be circuitous or tunneled or indirect or transition mode or limited capacity. In those cases, v4 might be a better choice. We're not going to go ahead and really go through talking about all the little bits and pieces of configuring your desktop. The reality is most desktops are going to auto-configure today with the exception of XP. This microscopic print will show you how to do it if you have XP. Under Mac OS, you need to go ahead and go through a couple of slides again, but we're running out of time, and we're not going to go ahead and go through that today, but you can see what you would go ahead and normally do. Your web browsers, Firefox supports v6. It's v6 aware, but you need to tell it to go ahead and use v6. By default, it actually chooses to use v4 for everything. So if you want to use v6, you just need to tell it to do so. Sometimes folks say, well, what can I look at over v6 on the web? Here's a list of some sites that you can go ahead and test against. Other web browsers, other graphical web browsers also support v6, things like Opera and Safari. Again, you might need to go ahead and do some tweaking with Safari, but the reality is you can make it work. Mail clients, most modern mail clients also support v6. Again, just like with Firefox, with Thunderbird, you need to go ahead and tweak it a little bit, but the reality is you can enable it, and then things like Thunderbird will work fine. There's not a lot in the way of publicly accessible IPv6 web email right now. For those of you who come to these things looking for market opportunities, well, there's a market opportunity for you. So as far as I know, there's only one of those right now. Some people may be able to also get to Google Gmail via v6, but the reality is a lot of folks don't really have a good v6 webmail solution. If you're a person who uses SSH and many other utilities are accessible over IPv6 as well, you may just have to throw in a -6 qualifier. Web servers, well, Apache and those sorts of things are v6 enableable as well. And one of the things you may want to go ahead and do is check to make sure if you have v6 connectivity, do you go ahead and have your web server v6 enabled? If not, here's a one-pager that, again, will get your web servers enabled. So none of these things are hard, you just need to go ahead and kind of get them done. When you do go ahead and enable V6 for your web servers, make sure you think about things like V6 addresses suddenly popping up in your log files. A lot of log file analyzer products are not necessarily going to be ready to do V6 without being patched or upgraded. So that's pretty much what I've got for you today. What I did want to go ahead and do is mention a couple of additional resources. There are plenty of books out there on V6 now. It's not like the old days. If you go to Amazon and look for V6, you're going to get almost 900 hits now, which just amazes me. That's a lot better than it used to be. One thing to keep in mind is some of those books were written for specific audiences, like programmers. If you're a programmer, find a programming book. If you're not, that's not what you want. So the point is go ahead and make sure you're careful about what sorts of books you pick if you're going shopping on Amazon for V6 stuff. And I would also say that because V6 has been evolving pretty rapidly, but it's been out there for like 20 years, beware of some stale titles you may bump into. Another thing that's kind of cool is this Hurricane Electric IPv6 certification program. It's a free thing. Anyone can go ahead and take it, and you can do it a module at a time. But it'll help you kind of work your way through all the topics we've talked about and a bunch more things. And at one point, they even went ahead and issued these cool sorts of t-shirts if you completed things. So you could get sort of the ultimate geek t-shirt with information about what the number of pennies it takes to fill the Empire State Building and things of that sort, and how that's a lot smaller than the number of IPv6 addresses you were going to get. So that's about what I've got for you today. I apologize for probably running us even a minute or two over, but if there are any questions, I'll be glad to go ahead and handle those out in the hall. And that way we won't have to worry about folks getting on camera.